All right, so we are cruising along on this online lecture thing. I noticed a few people have already watched my first lecture, so congrats to you for working ahead. So this is going to be the last lecture for chapter 14, and then I will start cruising on chapter 15. So just make sure you're checking my awesome essay, keeping up with the deadlines. Not everything, even though I'm posting stuff ahead of time, doesn't mean you have to do it ahead of time, okay? All right, so last thing for chapter 14 is on catalysts. So remember we talked about at the beginning of this chapter that there's 4 different things that affect a reaction rate. We said properties, concentration, temperature, and a catalyst. So now we're going to talk about that last thing, a catalyst. All right, so let's talk about what a catalyst is. So a catalyst is a substance that does a few things. First, it increases my reaction rate. It makes the reaction go faster, and it does this without being consumed. So when you dump the catalyst in, it makes the reaction go faster, and you can literally take the catalyst out at the end. Now that depends on if it's a solid or a liquid, how you actually separate it out. It's not like you could just like scoop it out like with your hand or something like that. But it's not gonna be reacted. So it's not gonna be a reactant that now turns into a product. So it's there at the beginning and it's there at the end. The way that it increases the reaction rate, it's going to change the mechanism. So how my reaction goes from point A to point B is gonna be different when there's a catalyst, when there's not a catalyst. So it changes my mechanism. The way that it changes the mechanism is it's gonna lower my EA. Remember, that's my activation energy. So it's gonna lower the activation energy in my rate limiting step. And the step that is the slowest step, it's gonna change how high my hill is. So remember, activation energy is the height of the hill. So it changes how high that hill has to be for the reaction to go. A catalyst does not change the products or their relative proportions. So how much I'm gonna make or what it is that I'm gonna make doesn't change. So if I'm trying to make B and C, it's still gonna make B and C, and it's still gonna make the same amount. It's just gonna make B and C faster, okay? So what I'm making is just faster. All right, so let's look at this. So this is 2-butene, and we're gonna do the isomerization of this. And it's gonna be catalyzed by I2. If you don't know what this is or this is, that's fine, okay? Just we're doing a reaction. The reaction is catalyzed by I2. That's all you need to know. So if there's no catalyst, my rate is equal to K times the concentration of cis-2-butene. Okay? If you don't know what cis is, that's fine. Just think rate is equal to K times my reactant. Okay? Now, that's before I add a catalyst. If I add some I2 into the reaction, it speeds up the reaction, but it's not used up. And so because of that, you don't write it as a reactant. It's not like plus I2 as a reactant. When you use a catalyst, a lot of the times you'll see the catalyst written right here on the arrow. Because it's not a reactant, because it's not going to be part of the reaction, it's not a product because it's not being made, it's going to be there at the beginning and the end. So a lot of times the catalyst is right here on the arrow. So if I want to write the reaction when it's catalyzed, I have to write it a little different. Rate is going to be equal to K. It's still going to be equal to my cis-2-butene. But now I have to take into account my I2. And in this case, it's a half I2, but you just have to know that now that catalyst is included in my rate law when I write it out. Also, you're gonna see that the K is a K prime. So this little line is a prime. Instead of it being just K, it's K prime. The reason is because this K is not the same as this K. So the uncatalyzed is not the same as the catalyzed because we said that I2 changes my rate. And remember, we can talk about K's in relation to the rate. okay? So my K's can't be the same because the rates aren't going to be the same, all right? Now, what this exponent is and all that, you don't have to know. I just want you to see that when we write the rate law is different for a catalyzed reaction, and my K is different. So you just need to know the theory behind this right now. All right, so I said that the way that it increases the rate is by it lowers the activation energy. So this picture shows that. So remember, activation energy is the height of my hill right here. So from where I start, right here's where I start, to the top of my hill, that's my activation energy, the height of my hill. So let's look at this. The purple one, the really tall hill, this one is uncatalyzed. So my tall hill right here is my uncatalyzed. So without a catalyst, I gotta go really high. I gotta get over that really top bump. What a catalyst does is it makes the hill shorter. So instead of having to go all the way over, now here, my catalyzed reaction, I don't have to go as high. So because I don't have to go as high, I have more particles that are gonna be with enough energy to be able to hit each other fast enough so that now they can make the transition states and go, okay? So a lot of people think, oh, the way that it works is like, oh, my catalyst just makes me go faster so I could go over the hill faster, like I'm driving over the hill faster. That's not the case. Think about a catalyst, instead of going over the hill, it's like it went and made a tunnel through the hill, okay? Now, the reason that this is only like one hill and this is like a bunch of little bumpy hills is because sometimes it's not one step, it might take more than one step. So these would be for each of the little steps in the mechanism. But what you need to know is that a catalyst lowers the activation energy. So it lowers the height of the hill, and that's why it goes so fast. All right, so some points that we need to take away. I2, this is my, whoop. It's like we're back in class and we have a bell. Sorry. So remember, I2 was my catalyst in my example. In this example, I2 was my catalyst. So what the I2 does is it dissociates and then reforms. So it doesn't just sit around there doing nothing. It is going to change form a little bit and kind of interact with the reactants, but it doesn't react. It interacts, but it doesn't react. So it's a little different, okay? Because it is not consumed. It is not in the overall equation. So I might say A plus B goes to C plus D. If I add a catalyst, then I would say my catalyst is right here. It's not a reactant, it's not a product. Most of the time, we would just write the reaction, and then in the words where we're talking about it, we would say it's catalyzed by so-and-so, okay? What happens is my activation energy is gonna be much lower. How much lower depends on the reaction. So before, in this example, it was 262, and then it dropped to 115. So my activation energy is a lot lower than it originally was, making my reaction a lot faster. In this case, it's 10 to the 15 times faster. So it's a lot faster than the original reaction was, okay? How much it is, you don't know that, okay? But the initial and final, where I start and where I end, is the same. So that's also really important. In a catalyzed or uncatalyzed, see the purple and the green, they both start in the same place and they both end in the exact same place. The only difference is that one has to go all the way over the hill. If it's uncatalyzed, one has to go the shorter version, a shorter hill. So the initial and final energies are identical if it's catalyzed versus not. So delta H is the same whether it's a catalyzed reaction or not catalyzed. All right, so that's the last of our stuff for chapter 14. Make sure you're checking Miles Massey for deadlines as far as the homework is due, the quiz is due, all of that. Check Miles Massey. Under the topics tab, all the information you need is right there. And I'm gonna start on chapter 15 and posting those shortly. Hope you're doing good. If you have any questions, shoot me an email.